So today, we started just an introduction of statistics. Um, and today we're going to look at a couple things, and starting with statistical tables and graphs. Okay. So, and there's going to be several that we're going to look at. And starting with the most basic thing, what we're going to call a frequency table. Okay, and give me 1 second here. All right. So, frequency table. Um, it has 2 columns. Uh, oh, man. Two columns. Um, First column lists all categories of the data. And second column um, lists the frequency for each category. Which is simply how many times you have an occurrence for that particular category. So, um, so as an example, let's just say I had uh, an assignment for a class. Let's say there were 25 students in the class, and I had a list of all their grades or the grade on the assignment for each individual student. So a frequency table from that situation would simply look like have one column, which is the categories, and that would be your grades. And so A, B, C, D, and F. And then your second column is simply labeled frequency. And so there were 4 A's and 7 B's and 9 C's and 3 D's and two F's. And you might have a last thing down here, just total, because this should total up to 25. I've kind of run out of room on my whiteboard, but 25 for your total. And that was simply a frequency table. So it's just that simple. It's just, again, we're looking at ways to organize data. Okay. Now, we may also put in, for a particular table, another column, which we'll call relative. And I'm missing my B. Relative frequency. So, and by now, anytime we've heard this term relative, we're thinking percentage, right? Or the number in decimal form, where it is the number in the top is the number for that particular category, and in the bottom we've got the total. So it's it's a fraction or a ratio. So in this particular case, relative frequency here would be 4 out of 25. Right, which as a percentage is 16% or 0.16. And if I looked at the rest of them, this would be 7 out of 25, which would be 28%. 9 out of 25, which 9 divided by 25 is 0.36, or 36%. 3 out of 25, which would be 12%. And 2 out of 25, which would be 8%. And this should add up be 100%. Okay. Now, you may also see one other column, sometimes associated here, which we'll call cumulative frequency. Now, cumulative frequency would look like this, and just think of the word accumulate as you go. So you would start out here with 4. Now, we're basically just adding on from here. So your next one would be 11 because you would be adding the 7. So up to that point, you would have 11. Next one would be adding the 9, which would give me 20. Next one would be adding the 3, so that would be 23. And then finally adding in the 2, which gave me, again, my total of 25. But it just adds as it goes along, and that's cumulative frequency. Okay. So frequency tables. All right. Now, data types that we deal with, and this I have actually used these terms before, but this will be the first time we've actually officially defined them. And we can have 2 types: qualitative and quantitative. Okay. So now, qualitative data. consists of values. So these are numbers, but values that can be placed into non-numerical categories. Can be placed in non-numerical categories. The quantitative represents counts or measurements. Measurements. Okay. So, just some quick examples. So, if I had just a label, is it qualitative or quantitative? Let's say I've got brand names of shoes in a consumer survey. That's non-numerical, so it's names of shoes. So that would be qualitative. If I had heights of students, now these are measurements, so that's going to be quantitative. If I were looking at audience ratings of a film on a scale of 1 to 5, 1 being bad, 5 being excellent. Now, that one's the tricky one. So, again, this is ratings 1 to 5. This, honestly, though, is qualitative. Even though you are assigning a number, it's an opinion. It's not a count, and it's not, you're not counting anything, and it's not a measurement. It's an opinion that we're using a number to express that opinion. So, um, so again, if it's going to be quantitative, it's got to be a count or a measurement. All right. Now, sometimes when we're looking at a frequency table, and we're dealing with quantitative data, and you're looking at a whole range of numbers, we may want to what's called bin, put our data into bins, and just think of it like a holder for each particular number that it would fit into. So, as an example, let's say I've got a set of 20 scores on a 100-point exam. And so let's say, so example, and I got 20 scores on a 100-point exam. And the scores range from 72 to 98. So the scores fall anywhere from 72 to 98. All right. So I may choose to bin these in 5-point bins. What would that look like? Something like this. So here would be a bin. Now, that's 5 scores, count from 70 to 74. Then I would go 75 to 79, and then I would go 80 to 84, 85 to 89. And then I could go 90 to 94, and then 95 to 99. Now I'm assured, since the range was from the lowest of 72 to the highest of 98, that all of them will fit within one of these bins. All right. And so then I could build out my frequency table from there. And so here's my bins. Label it scores. And then I'm going to have frequency, which I'm just going to use F. So just an F for frequency. Now, without actually writing down all the individual scores, but that's if you were building this table, you would have all the scores listed out, and you would then go through and figure out how many scores would fit into each one of these bins. And I would have, so 1 score between 95 and 99, and 2 here, 3, and 3, and 7, and 4. And then that should add up to your total, which those numbers would add up to be 20 scores. Then we could do a relative frequency. And again, this would be 1 divided by 20, and this would be 2 divided by 20. I'm going to put these in decimal form. So 0.05, 2 over 20 is 0.1. 3 over 20 is 0.15. So that's also 0.15. 7 over 20 is 0.35. And 4 over 20 is 0.2. And then that all should add up to be 1, or in percentages, 100%. And then, of course, we could do a cumulative frequency. And I would have 1, 3. So you just 1 plus 2, and it's literally just adding down the line. So this would be 1 plus 2 plus 3, which would be 6. Adding in would be 9. Add in the 7 would be 16. And then adding in the 4 gives me my 20. So that last number should, always be equivalent to that. Okay. So sometimes you will see, again, the categories for quantitative data arranged in bins. Okay. All right. Now, unfortunately, here's where, and I have my math lab up on my other computer, so I can't show you the graphics per se. But what we want to look at now are different types of visual displays that we can use for data. And the first 2 types I want to consider are for qualitative data. And these we will refer to as bar graphs and pie charts. Again, these are used when I have qualitative data. Okay. All right, so if I were to construct, and that's how I'm going to show these by example for our grades. So got the assignment we had, and so I'm just basically going to try to reproduce this as best I can. And this is going to be a bar graph. And I'm going to have an A, a B, a C, a D, an F. And I'm going to go up this column. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And this, this is interesting. It does not allow me to write easily sideways. Frequency of grades, but I want to label that. I apologize for the messiness. My little tablet here does not allow me to write vertically very well. Up here, the title of the said pie chart, or excuse me, bar graph, which was the grade data. Okay. And up this column, oh, geez, cow. Sorry, guys, I'm just technical difficulties. All right, best I can do up this one. On this column right, or up this side right here, is going to be my relative frequency. And I'm just going to abbreviate it. So, and I would organize it by gaps to something that made sense. I'm going to do it by, in this case, 4s. So 4%, 8%, 12%, 16%, 20%, 24, 28, 32, and then 36%. All right, so there were 4 A's. And I'm going to try to draw that just in there a little bit better. And I just use bars. There were 7 B's. So there. There were 9 C's. Take your assignment. And there were 3 D's. And there were 2 F's. Okay. All right, so this goes with that first frequency table that I built at the very beginning. And this will be organizing it into, again, what we call a bar graph, which is used for qualitative data. One important distinction, because we're going to have another type of bar graph that we're going to give a different name to. We're going to call it a histogram. And it's for quantitative data. It's basically bar graph for quantitative data. And the bars are together. And a bar graph, that's the quickest visual way to tell the difference when you have a bar graph or a histogram. In a bar graph, the bars are separated. All right. Now I can take the same data from that frequency table we built at the beginning and also put it into the visual display called a pie chart. All right, now this is even going to be a little bit more difficult for me. So the first thing I got to try to do is draw a circle, which I'm not terribly good at. And this tablet's not going to help me. But just like a piece of pie. So just imagine that was circle-ish. All right. And there would be a center of the circle. And what I use here are the relative frequencies, those percentages. Now, the way you would actually construct a pie chart is knowing that a circle in degrees makes 360 degrees total. And then you would use a tool called a protractor that measure out angles. You set your protractor center right on the center of the circle and you measure out an angle. And what it would be is, so for like A's, the relative frequency for the number of A's was 16%. Notice I come up here to 4, and it's supposed to match up over here with the 16% right there. But you can also, I mean, just look at the frequency table and pull that off of there. But it's 16%. So what angle do I measure out to represent that portion of the piece of pie? It's 16% of 360, or 360 times 0.16, which would be 57.6. So round to 58 degrees. And you would measure out a 58-degree angle. So I'm just eyeballing this. But you'd measure out that angle around, yeah, that's not probably wide enough. Get a little bit wider. Right. Do that. And say, okay, that's representing my A's. And that again, 16%. And then you would do the same for all the rest. Have B's. And that was 28%. So the piece of pie is proportional to the percentage of that grade. C was the most, it was 36%. And D was 12%. And we'll put D here, 12%. And F's were 8%. So again, this one, well, these percentages add up to 100%. But to figure out, the angle, if you were doing it by hand, again, you would multiply it by 360. Percentage is a decimal. Figure out then what angle to construct. Of course, with software, you can just put in a command and it'll give you the angle and construct it for you. The other thing that's missing from each of these two graphs is the color. So you're able to be able to go in and color each one of these, make them a different color, make it stand out, pop a little bit more. You would have a label here, just the same, grade data. But what you don't see here is, again, the frequency on the pie chart. You don't see the frequencies there. Just the percentages. Okay. So, again, two types of visual displays we can use for qualitative data, by bar graphs and pie charts. Okay. All right. So let's talk about quantitative data and visual types of visual displays for those. page. And these we're going to call histograms and line charts. And these are visual displays for quantitative data. Okay. So let's do an example for each of these, and we'll use the frequency table where I arrange the grades into the bins, B-I-N-S. Right? So this will be a histogram. And so I may, on my horizontal, start at what, 70, then to 75, to 80, then to 85, to 90, then 95, and 100. And then frequency, 1, 2, of course this bottom one is 0, 3, 4, 5, 6, 7, 8, 9, and 10. All right. Now, I'm going to draw this as neatly as I can. And this next one's going up to 7. Too far. So I have 3. So something like that. And then 2. Okay. And again, try to write sideways as best I can. That's a little bit better. Okay. And these were exam scores. Okay. So this would be an example of a histogram. So you notice the bars are together. And it's because I have arranged, and this goes with, and I will turn back to this page, but I want to go back to this right here. This is where I'm pulling to build the histogram, where I had arranged these in these bins. Notice it went 70 to 74, it was by 5, and then 75 to 90, 79, and 80 to 84, 85 to 89, etc. And when I look at the histogram, I went down this horizontal column and said 70 to 75. So that the way it works is, if say I had a score of 70, it would go into this bar. If I had a score of 75, it goes into this bar. So scores between 70 and 74 slip just solely into that bar the way it should. So when I arrange my, do the histogram, if my bin was going 70 to 74, then I would do this 70 to 75, so on and so forth. So I clearly know where each goes in here. And again, I could do these in color, so on and so forth. All right, so that is again, histogram. Now, If I were to do a line chart, it would be arranged in exactly the same way. That is, I would have 0 and 1, 2, 3, 4. And these would be uniform. My handwriting does not allow me to make these completely uniform. That is the gap in between each tick mark. 9 and 10. And then I have my 70, 75, and 80, 85, 90, 95, and 100. And what I do here is, again, there were 4 that were between 70 and 74. So what I do is halfway between, I put a point for the 4. There were 7 that were between 75 and 79. So I go up halfway between here and here. And there's my, about right there. And then there were 3, each of these, so 3. And then between 85 and 90, again, 3. Then we were at 2. And there was 1. Okay. All right, so again, this is going to be an example of a line chart. So what I do is, and I wish I could draw a straight line, but boom, play, again, connect the dot. Just literally like that. Okay. And then down, carry it down to the corner of the graph right there. So straight lines. So everything was exactly the same. This will again want to be labeled scores. Labeled scores. And this was labeled frequency. And your exam scores. Okay. So, so as far as the vertical and horizontal axis, each of these are exactly the same. It's just a little bit different visual display. You can clearly still see where you had the most frequency. And you can kind of see with drop off. And we'll be able to also look at what we're going to call skewness. That is SKEW, which will be our next topic when we are talking about distribution of data. You can visually see it on either of the 2 graphs. And again, this was histogram, and this was line chart. Okay. One other type of line chart, and I'm not going to try to draw it, is called a time series graph, but it is a line chart. But basically, your horizontal axis is time. It may be by months, it may be by years, but it's construct. Everything else is the same, and you would play connect the dot. That is it. So, and that really is everything in this particular section in terms of graphs. So we really looked at 4 types of visual displays. Started off with what we called a frequency table. discuss the difference between qualitative and quantitative data. Two types of visual displays for quantitative or qualitative, which were pie charts and bar graphs, and then two types of visual displays for quantitative, histograms and line charts. Okay. And then we again may see one other type of line chart called time series, but it's just the horizontal axis represents time. Okay, so on the homework itself from 5C, you'll be looking at basically there are 19 problems total, and several problems just dealing with making sure you understand the difference between the four types of visual displays, definitions of them. And just making sure there isn't anything too. They're fairly straightforward types of problems, honestly. Okay. Should be able to do that okay. Should be good. All right. So, the next thing that I want to go into is looking at ways that I can characterize data. In what we're going to two different things. We're going to look at what we call measures of central tendency and measures of dispersion or variation. That is, so measures of central tendency, where's the middle? And there's a couple, at least two big ways to do that. But where's the middle of the data? When I'm talking about measures of variation, how's the data spread? And there's a couple different ways we can go about that as well. But I'm going to save that for Wednesday. We are still dragging a bit in terms of getting work done. Not everybody, but there are some folks running behind. And we have basically 2 weeks left. We have this week and next week. The session is going to end. Basically, I'm going to give you through the 7th of August. And we will have 3 more class meetings past today to get everything done. And so we are coming down to the end. But on Wednesday, I'm going to take up those 2 topics, measures of central tendency and measures of dispersion, and look at things we call mean, median, and mode, things we call standard deviation, quartiles and percentiles and deciles and things of that nature. And that'll be Wednesday discussion. And then we're going to look at a few things from the world of probability next week, and that will wrap things up. So let me go ahead